Hi, everyone. Welcome to the Orlando.NET User Group, June 17th, 2021 meetup featuring Khalid Abuhakmeh. Hopefully I got your name right.
Yep, you got it. Great.
This meeting is being recorded, so if you don't like being recorded, this is your chance to make sure your privacy is okay and drop off. Orlando, this meeting is run by the organizers of the Orlando.NET User Group and Orlando Code Camp, and these are our board members. If you're interested in joining, or we have a bunch of meetups coming up. So either way, this is a fun group to be associated with. These are some of our resources, and the best place to follow us is on meetup.com/onetug, Orlando.NET User Group, or and on Twitter at onetug. So we also have other things, but I need to update the Twitch link. I'll remind me to do that next time. So upcoming meetings, really excited to announce today's meeting and upcoming meetings. June 24th, we have Layla on Azure Functions. July 1st, Jason Bach on C# source generators. July 15th, Chris Woodruff, Web APIs. July 27th, Sean Colleen on Actor Model and Akka.NET. And August 12th, Sivakumar will be talking about GitOps with Flux v2 and Flagger. I'm not sure what those are, but I have worked with Azure Kubernetes Service, so I'm definitely looking forward to this. Monthly sponsor, if you're interested in sponsoring these meetups, hit me up. And community members, if you're interested in sponsoring, you can go to securemeetup/onetug/contribute. Any community announcements, any interesting projects anyone's working on, or any events coming up, please feel free to talk about that right now, or I can move on. Anyone? No?
I guess I could plug next week. We have at JetBrains, we have Dockers for Absolute Beginners webinar with Jonathan Turner. So if anyone's interested or heard about Docker but really hasn't gotten into it, I really recommend that. He's given that talk before, but the webinar has some new stuff in it, so it'll be exciting. So anybody interested in that can head on over to JetBrains and check that out.
Yeah, thanks, Khalid. And tonight's agenda, obviously, we have this intro. The talk is being recorded. It will be available on YouTube. I will post the link on our meetup page after the video becomes available. And Khalid, if you have any slides or any code you want to share, you can just post that in the meetup page, or you can simply add it to chat here, and I'll make that part of the show notes. And
okay.
Then on to our guests. I should have updated this, but Khalid, welcome, Khalid. I will hand it over to you. Khalid is, I have followed him a long time on Twitter. He's one of the, people, very interesting people that you meet on Twitter. He is a JetBrains developer avocado. He claims he has over 15 years in the .NET space. Okay.
Thanks.
Khalid has a great blog, khalidabuhakmeh.com. And according to him, he's that's the greatest blog in the world. If you ever follow him on Twitter, you would know that. He focuses on ASP.NET technologies, web technologies, database tooling, and I recommend connecting him up with him on Twitter and following him on his blog. So Khalid, I'll hand it over to you. Just introduce yourself, but I'm also interested in knowing, how you got, how you got to where you are. So, just kind of give us a brief intro about yourself and what you're currently doing. And, that I'll hand it over to you.
Okay. Thanks again for having me. I'm really excited to be here. talking to user groups and talking to developers. It's really fun for me. I like to geek out. So Santosh said that I've been doing .NET for 15 years. Honestly, I've kind of lost count right now. And if you're like me, as .NET has evolved and new features come out, every year feels like the first year, right? So I would consider myself as today a junior developer in the .NET space, just because there's just so much happening. But I've been doing .NET since version 1 in college. That's kind of when I learned C#, and I've worked for big companies, small companies, all the way from being a junior developer up to being a director of software development. And today I'm a developer advocate for JetBrains in the .NET space, primarily representing tools like ReSharper, Rider, .memory, .peak. If you're familiar with those tools, that's great. We primarily try to help .NET developers develop the apps that they want to develop. So other than that, I basically just hang out on Twitter and I talk to .NET developers. I do open source, and I have some samples on GitHub as like crazy experiment repositories. So I'm constantly experimenting with .NET and kind of seeing what's possible out there. Other than that, I like to travel. So if you follow me on Twitter, you'll probably see pictures of me traveling. Right now, you're only going to see pictures of me and my dogs, Samson and Guinness. And yeah, other than that, yeah, I'm just hanging out until this whole pandemic thing kind of ends. So that's really it. I don't know if there's really much else to me. What you see is what you get on Twitter. So good or bad. So, all right. Should I get started?
Yeah, please go ahead.
Okay. I'm going to share my screen. Let me know when you can see it. Let me get out of here, Teams. All right. Okay. So today, I've been kind of experimenting with Entity Framework Core over the last couple years and just seeing where it's evolved from its inception.
Khalid, I was supposed to see a slide.
Yeah. Do you not see it?
No, I just see. Okay, now I see it.
Okay, so I'll just do it this way. It must be when I go full screen and Teams doesn't pick it up. So yeah, I'll just do it this way. That'll be fine. So yeah, I've been just kind of looking at Entity Framework Core, seeing where the Entity Framework Core team is going, and yeah, to be honest with you, when I came into Entity Framework Core, I've been using Entity Framework proper. Mostly Entity Framework 5 and 6 for, the better part of 5 years. And I thought a lot of that information and that knowledge would transfer over to Entity Framework Core. To my surprise, as I look through Entity Framework Core, I guess I'm going to say Entity Framework Core a lot, but as I look through EF Core, I noticed how much had been rewritten from the ground up. And while there are similarities with the link API, a lot of my knowledge that I thought would carry over from EF, like the intricacies and the internals, really kind of don't. And you'll kind of see this as we go through the slides. So we kind of went over who I am. My name is Khalid Abuhakmeh. You can follow me at Twitter at Buhakmeh. That's kind of cute, but yeah. I would consider myself an ASP.NET professional. I'm an advocate for JetBrains, and you can go to abuhakmeh.com. You can also get to my blog, funnily enough, through khalidforamerica.com. Through the whole political season, I thought it was funny that I could purchase that domain. So yeah, that works. I also consider myself a meme artisan and Photoshop hobbyist. This talk has been reviewed by the mayor of Orlando, so I think it's going to be good. So as I go through these slides, I just want you to keep in mind the golden rule of software development, like anything, context matters. Everything comes with an asterisk. It depends. So if I say something, and you should think about it and see whether it applies to you specifically. There are circumstances where some of these pitfalls, you may actually want to lean into them for your particular case. And I can't know what your context is. You know what your context is. So again, as I go through these slides, it depends. So for folks who don't know what Entity Framework Core is, Entity Framework Core is an object relational mapper. It really helps people access databases. In the .NET space, people access relational databases for the most part. Early on in the chat, somebody mentioned Cosmos DB, which is mostly a document database. It has a SQL. It supports SQL, but I wouldn't consider it a relational database. Object relational mappers are really designed to help pave over the impedance mismatch between something like a relational database and C#, which is object oriented. You have data objects and references and stuff like that. So again, object relational mappers do that, and Entity Framework Core is definitely one of them. One of the more other popular ORMs is NHibernate, and they're kind of similar. From a developer's point of view, Entity Framework is going to look mostly like what you see right now on the screen. You're either going to be dealing with an abstraction of a DB context. Here we have a DB context that's using a SQLite data provider, and we have several objects: productions, movies, series ratings. And that's kind of what you'll be dealing with in code. From the command line, Entity Framework Core comes with this really powerful CLI toolset, and it allows us to do things like manage the database, update our DB context in code with things like database migrations. So from a developer's experience, these are kind of the two things that you'll be ping-ponging back and forth through. So as we go through these slides, or as we go through the jungle, I don't know if folks have noticed the pitfall background, but it's there. We'll be starting with some of the pitfalls you might run into when setting up your EF Core projects, particularly with the environment. And then we'll talk about some design decision pitfalls that you might fall into and might want to avoid as you kind of build out your application. Querying is the lifeblood of any EF Core application. So if you're going to make a mistake, it's likely going to be when you query data out of a database. We'll cover some things and how EF Core might have changed since Entity Framework, and maybe how to avoid those mistakes. We'll also discuss a lot of the internals. We talked about how ORMs kind of pave over some of the impedance mismatch. ORMs have kind of been described as a leaky abstraction in the past. And yeah, like Entity Framework Core is no different. While it is a decent abstraction, you still kind of have to understand what's happening internally. We'll talk about that and see some of the mistakes we could make there and maybe how to avoid them as well. And then finally, once we built our EF Core application, we'll talk about some of the pitfalls when it comes to deploying our app. So let's start with environment. The first thing I noticed different than Entity Framework 6, the predecessor to EF Core, is the CLI tooling that I mentioned previously. And a lot of the Microsoft documentation right now suggests that you install .NET tools globally. Only recently, I think with .NET 3 or .NET 5, could you start installing tools locally within the scope of your project. But the last time I checked, the documentation still suggests you install Entity Framework core tooling globally, which for me, I think is probably not what I would recommend to you. Install it locally. That way the version number that you reference inside your project matches the tooling version number. So to do that from a command line, we want to open a command line within our solution project. We want to run the command .NET new tool manifest. What this will do is it'll create a new .config folder. And in that folder, there will be this JSON file created. This JSON file holds kind of any tool that we install locally for our solution, and that also includes EF Core's CLI tooling. After we've run the tool manifest, we want to install the .NET EF Core CLI tooling. So we just run .NET tool install .NET-EF. The documentation right now has the -- global flag. Again, exclude that. The .NET install process will determine that you have this tool manifest file and go ahead and install EF Core locally. So now anytime you run .NET EF, it'll use the right version of EF Core command line tooling. The second environmental mistake that I've seen several people do, especially when it comes to both writing their application and then wanting tests, is maybe trying to change out the database as they build their application. And it might seem obvious to say this, but not all databases are the same, right? So Entity Framework Core supports databases like Postgres, SQL Server, Cosmos DB, MySQL, SQLite. I think I saw DB2. I'm pretty sure DB2 was on the list on the official Microsoft documentation site. So if you work at a big enterprise, you'll likely run into that database. But clearly, all these databases have a relational style model, or they support some kind of SQL, but their behavior differs wildly. If you look at the behavior of SQLite versus full-blown SQL Server, you may be able to get away with basic SQL queries, but even then the SQL syntax between those two databases is going to be slightly different. The problem we're going to run into is if we think that switching our database out for tests, we may pass all of our tests, deploy our application, and then in production, all hell breaks loose. And that's not what we want. So given the current state of development and with tools like Docker and being able to run those locally, pick one database, stick with that database, you'll be a happy camper. Speaking of databases, right from the start, you want to pick a good database tool. An ORM is not an excuse to avoid the database completely. You're not going to be able to just stay in C# in your .NET IDE of choice indefinitely. You're going to have to go to the database. You're going to have to look at the schema, indices, foreign keys. So pick a good database tool. Working at JetBrains, I can recommend that you use tools like DataGrip, which is our database tool. Writer has DataGrip built into it. So if you develop your .NET applications inside of Writer, you can use the database tool window and you have all the same functionality as DataGrip. I also like Azure Data Studio, but that's also limited to the databases that are supported inside of Azure. So your mileage may vary there depending on what database provider you've chosen. And then if you're only using something like Postgres, it has its own administrative tool. So I recommend pgadmin. All right, let's talk about design decisions. If you work at an enterprise, which I imagine a lot of .NET developers work at enterprise, there's different discipline based teams. So you have your developers, you have your DBAs, you might have your business analysts. DBAs are an interesting bunch. They have their own naming conventions, their own styles, their own idioms. And just like us C# or F# developers, they want to stick to those idioms. They may be tempted to design the database first and go schema first, which Entity Framework Core supports. But from my experience, both with EF6 and EF Core, you start to get, it starts to add a lot more overhead to your projects. So using a non-conventional naming scheme, things with prefixes like TBL and PK for primary keys, EF Core can support those naming conventions, but you start to find your code base is polluted with attributes and mapping. And as your DB context grows, you'll find yourself spending a lot of time just fine-tuning those mappings. So just save yourself the headache. Use the default naming conventions in Entity Framework Core. And as the Entity Framework Core team evolves the library, they have your use case, the standard naming use case in mind, and it'll just make upgrading a lot easier. So yeah, just try to convince your DBA, be nice to them, maybe buy them some chocolates. It'll be okay. So, okay, let's say you're working at this enterprise. The DBAs have decided to go schema first. They've named everything the way they want to name it. And now you're nervous, right? You sit down to start your Entity Framework Core project, and you start building out your classes. You're manually doing all your mappings. Things aren't going well because when you write a query, it just isn't right. Something is wrong. Entity Framework's throwing exceptions. Well, with the new EF Core .NET CLI tooling, scaffolding is built right in to the tooling. And I think a lot of people forget this. And this is a great shortcut, whether you use it as is when you run the scaffolding, or just use it to kind of double check your manual mapping. So running this command, .NET EF DB context scaffold, you want to pass it a connection string, and then you also want to pass it your SQL database provider. In this case, I have SQL Server. I've used this a lot, especially when I go ahead and I download a database just to kind of see what Entity Framework Core thinks. There are limitations, though. As you'll see later in this slide, there are approaches to inheritance that you can do in Entity Framework Core. All the inheritance knowledge is actually stored in code, and there's no way to actually represent it in the SQL schema. So Entity Framework Core can't figure that kind of stuff out. Otherwise, though, this tooling is pretty good. Speaking of inheritance, there are actually two inheritance approaches when we talk about EF Core. One of those is table per type. This has its place, but if you think you need it, you need to like triple check that you actually need this approach. I thought I've made this mistake in the past. I thought, oh, table per type, it creates these really, really pretty diagrams, and the DBAs seem to like how this looks and how this is normalized in the database. Well, yes, it's normalized, but look at this example, right? From the previous diagram here, we have a base type of course, and then we have these derived tables of online course and on-site course. I've gone ahead and I made multiple other courses, things like private courses and self-guided courses. And a course also has a department that it's related to. On the left, we see our link query, where we're trying to figure out what are all the courses in our database, and we also want to know what department that course is part of. That link statement on the left, it looks harmless, but then when you look at the link statement on the right, we're joining up to 6 tables in a single query. Excuse me for a second, I just got a cough. So you can probably imagine as your inheritance structure kind of grows, you add more tables to this inheritance hierarchy. This query is going to get out of control very quickly, and performance is just going to nosedive. So while this approach works, I wouldn't recommend it. The only time I would recommend it is if you treat each course or entity as separate from the hierarchy, and you only access it as the entity itself, not as the base table. So in this case, I wouldn't call courses. I would only get all the online courses. And at that point, you're only ever going to join 2 tables. So table per type, I wouldn't recommend it, but if you need to do it, yeah, that's the way I would recommend using it. Okay. If you're going to do data inheritance in Entity Framework Core, what you really want is table per hierarchy, meaning no matter how many entities you create in an inheritance hierarchy, wow, that's hard to say, they will all be stored in a single table. The way you differentiate each type is by a specific column called the discriminator column. Entity Framework Core will see that as the data comes back from a query, and then pick the appropriate type, C# type. Usually matches the name of your C# type, the value that ends up in this discriminator column. So it's very easy to query, even if you're not using EF Core's link query interface. This is nice, but it does have some drawbacks. One of the drawbacks, obviously, if you have many types and those types don't have a lot of overlap, you're going to have rows with a lot of null values in them. So if you don't like that, this may not be an approach for you as well. But in terms of performance, I find this is way better than table per type, especially if you're going to do those queries based on the base type. Okay, so as a developer advocate, I've made this terrible mistake. Luckily, it only happens in demos, so it's safe from a production database near you. But EF Core has this concept of seed data, which is really nice. But the thing I didn't realize is what Entity Framework Core does is when it sees this model builder.entity has data, when you go to create a database migration, it actually formalizes that data into your database migrations. So below, you can see some code pulled from a single migration. And yeah, I think I had like 100 rows here, and in our DB migration, you'll have 100 insert data calls. This is nice, but for me personally, I normally like to randomize my data. So every time I went to go create a new migration, it would actually delete all the data and reformalize the insert statements, and it made my migrations huge, right? So be careful. If you want test data, you probably want to do it as an afterthought, not use this seed data mechanism. This seed data mechanism is probably for things like lookup tables. So if you have a specific table that maybe has description data, those kind of things make sense to use for seed data, but not test data. So try to avoid this. You'll thank me. Okay, so the bread and butter of any EF Core application is going to be querying. And if you take anything away from this talk today, this has really changed how I use Entity Framework and how I use link-based querying um, interfaces, even in Hibernate. But you want to treat all of the entities that you end up creating in your projects, in your solutions, treat them as representations of your database tables. They may look like C# classes, and you can put C# constructs in them, but it's normally a mistake to do that. As an example here, we have a production entity, which is a base class. And then we have this getter helper property of average rating. Here we're accessing the ratings collection, and we're calling the link method average and trying to average the stars given to this particular production. What's wrong here, and why I implore you to think about these classes as a representation of the tables in the database, is this ratings collection, the data that ends up being in it depends on the queries you end up writing later. So when we look at this class here, we never know what's going to be in that ratings collection just by looking at this class. Again, it's a representation of the table in the database. So yeah, avoid these helper properties, avoid private state if you can avoid it. Yeah, most of the stuff just ends up kind of biting you in the long run. So don't do this. Treat these entities as representations of the underlying schema. Okay, this is controversial. I'm pretty sure people are going to boo me if people find this video on YouTube. They're going to downvote it. It's fine. I can take it. But one of the most frustrating things I see when folks start using EF Core, and actually I ended up helping somebody over the weekend with this particular issue. Folks wrapping the DB context, which itself is a unit of work, like pattern, they end up wrapping this thing in a repository or a service. And it actually takes away the strength of EF Core and ORM. So for me, this is almost too prevalent in our community. Repositories have their place when you're implementing things maybe with raw ADO.NET, but if you're using EF Core, this is for me an anti-pattern. I think the problem though, it's kind of the potato chips of our .NET community. Today I was just curious how many folks have written blog posts about the repository pattern and how to wrap things, and there's 1.4 million results just from Google. Even the top result is one from the Microsoft documentation site. Granted, it's only from 2013. So this to me is a big anti-pattern, especially if you're using EF Core. Don't do this. You're basically neutering any benefit from Entity Framework Core. All right, I can hear the boos, by the way, but it's okay. It's okay. Another mistake, I've been guilty of this, especially when you're just starting to prototype an EF Core application. You may inadvertently call toList async without actually limiting the data that comes back from the database. Here we have a query where we're looking at the productions table, and we just want to pull that data back ordered by the average rating in the database. But we've made the mistake of calling toList async, which is an unbounded query, meaning as the database grows, our query results will match the growth of our table. So locally, we might be working with 10 records, 100 records, maybe even 1,000 records, and it's still pretty snappy. in terms of our application performance profile. We think it's good, we push it into production, and now we have a ticking time bomb where as our data grows, as we get more users, this is a mistake. So be mindful. You want to use skip and take to limit the amount of data, the potential amount of data that comes back. There's a NuGet package called page list, which I really like. That works pretty well, but that also has a potential performance bug in it. But we can talk about that after this talk. So when you're building database-driven applications, network I/O is going to be likely one of your biggest bottlenecks in terms of performance. So you want to limit your network round trips. Especially in a cloud environment, you're going to have things like transient errors. Luckily, Entity Framework Core has execution strategies for retrying on transient errors. But for the most part, you want to reduce the amount of network calls when you're running queries. Luckily, EF Core has the include method, which allows us to generate joins when calling our data. So you'll see on the next slide what Entity Framework Core is going to generate with this particular link query where we're pulling movies and the characters that are in those movies. On the left-hand side, you can see the join SQL statement, but you can see immediately that there's kind of something weird happening. If you're familiar with SQL, we're joining those two tables, which means each row is going to have duplicate data. I just said running multiple queries is potentially a pitfall of an application. You should eliminate it. But you should also be mindful of the amount of data that you pull back from the database. And in some instances, running multiple queries will actually be better for you and the performance of your application. In this example, you can see the movie data is repeated in all 3 lines. In this case, it's not that big a deal, and I probably wouldn't optimize this. But again, you're pulling back repeated data. If you're pulling back 1,000 rows because of a join, you may want to consider splitting up those queries into multiple calls to the database. Here's the same result set on the right, where we're pulling the movie, we get 1 row, and then we get the characters, and that's 3 rows. And it's a lot less data coming over the network, even though it's 2 network calls. So again, you want to kind of measure and think about, is it better to run 1 query with a lot of joins, or is it better to run multiple queries? Luckily, with Entity Framework Core, they've introduced this new method, which is really, in my opinion, very cool. It's called as split query. And what it does is it still allows you to use that include call, but instead of creating a join, Entity Framework Core will just make those multiple calls for you. So it allows you to fine tune without ultimately changing the intention of a query and kind of fine tune each part of your application as you need it. So here you can see the results. We get our first SQL statement, and then the output basically says that Entity Framework Core will split that query. So yeah, this is very cool. I think this is excellent. This is an excellent feature, but keep in mind you want to measure these things. We've talked a lot about entities up to this point, but I think a lot of folks forget with link, you don't actually have to deal with those entities when you're writing a query. In this case, projections are very, very powerful. And for me, someone who's worked in ASP.NET, I find projections very valuable for using entities as a representation of my database, and then ultimately mapping a projection into something like a response object that will be passed over the network. So use projections, limit the amount of data that comes back, but then you can also use those entities to create really, really expressive link queries. So don't forget about projections. Don't pull any data that is unnecessary to get the job done. So, yeah, this is one I'm completely guilty of, especially when pushing for a feature and a release. But going with the first link query that you write, sometimes it might look good for what you want to accomplish, but you want to look at things like, what's the SQL that's getting generated? What are the results being returned from that SQL? And link queries are never written once and never looked at again. They evolve. So when you write a link query, think about how it's going to evolve. Are you going to add more filtering? Is there going to be more data returned in the future? Is there going to be a new relationship that has to be added to that link query? If the complexity starts to get a little bit out of control, you probably want to revisit those link queries. And remember, I've had to say this to myself and to other developers, EF Core is not magic. Yes, their logo is a unicorn, but EF Core itself is not magical. It doesn't know what you intend to do and the data that you decide to pull from the database. It literally takes your link statements and it translates them into SQL, and it does that by taking the link that you write. So here on the left, we have a link statement. It looks okay from a C# perspective, from a link perspective. It doesn't look that scary. But this link statement actually generates the SQL that you see on the right. I've gone through this and I think I counted at least 6 or 7 subqueries. It's not to say that the SQL is probably, it's not to say that the SQL is bad or might not be performant. But if you show this to, say, like your DBA, they might cry a little bit. You don't want to make anybody cry, but this may not actually be what you intend to do. So keep in mind what you write in link will translate to SQL, and it might not be what you actually want. Okay, so we've talked a lot about querying, but let's start talking about the internals of Entity Framework Core, because once you start understanding the internals of Entity Framework Core, you can avoid a lot of the performance problems that come with it. This one's easy. If you're coming from an Entity Framework 6 background, the Entity Framework Core team has done you a favor and disabled lazy loading right from the start. Lazy loading is when you access a navigation property. In this case, we have a rating entity, which is associated with a production. If lazy loading was enabled, whenever we access that production entity, we would make a subsequent database call. In this for each loop, for every rating, we would make an additional SQL query, and that would be bad. This is the N+1 problem. You've probably heard about it. And this can be a performance killer. So you don't want to enable lazy loading, just avoid it. Interestingly enough, though, when I was dealing with nhibernate, I found that lazy loading is something that's very difficult to disable with nhibernate. It's almost like a core feature of that. So it's kind of interesting, the philosophy between where EF Core is and nhibernate is. But for me, ultimately, lazy loading is like passing around a live hand grenade. You kind of never know when it's going to go off and when something's going to accidentally touch a navigation property. So yeah, I wouldn't recommend this, and don't enable it. And if someone on your team is saying you need lazy loading, definitely talk to them, think about it. You might need it, but for me in the past, it's been kind of a train wreck. when it comes to performance. All right. Okay. If you built your EF Core application, you have your queries, your results are coming back, and you're finding performance isn't kind of where you want it to be, this is probably the best thing you can do with an EF Core application, which is investigate what entities are being tracked, how they're being tracked, and whether you need tracking at all. So by default, when you run a link query in Entity Framework Core, every entity is tracked. So Entity Framework Core and most ORMs will take your entity into memory, and as you change that entity, it'll keep a log of each change in that entity. That's how it ultimately generates the SQL it needs to update the data back into the database. As you might guess, this is probably expensive. It is expensive. So why would you opt into this if you're only reading data from a database only to write it out to, say, a web response immediately? Well, luckily, Entity Framework Core has this method called as-no-tracking. So when you're starting to create your link query, you want to apply as-no-tracking in scenarios where you're only reading data from the database and have no intention to actually update the data back into the database. This opts your query out of that tracking and makes your application run faster, which is probably what you want in these scenarios. There is a caveat though with this. If the data being pulled back from your database is duplicate data, Entity Framework Core will actually remap that entity and recreate that object, creating memory overhead. So as-no-tracking opts out of everything, but it actually could end up using more memory depending on the result set that comes back from the database. With Entity Framework Core, at least in 5, they added a method called as-no-tracking with identity resolution. In a parent-child style relationship, if you enable this method, what Entity Framework will do is opt into this very narrow feature set where it looks at the primary key of your entities coming back. And if it notices that that key had already been processed, it just adds a reference to that object to where it needs to go. So that can actually reduce your memory overhead a lot by using this. It's not as performant as no-tracking in terms of speed, but it's definitely more performant when it comes to memory utilization. So those are the 3 types of object tracking that come in Entity Framework Core. Knowing them can really help you fine-tune your application's performance profile. All right. This is an interesting one that I found kind of scouring through the EF Core documentation site. And as you'll see later, there's actually a lot happening internally with EF Core, and there's a lot of caching happening inside. We've talked a lot about link expressions up to this point, and the way Entity Framework translates those link expressions into SQL, it has to process this expression type in C#. These types are very, very expensive to parse, like very expensive. This is probably the #1 reason people avoid Entity Framework. In my opinion, if I had to guess why they avoid Entity Framework Core, the performance bottleneck that comes from parsing these expressions is very expensive. The way Entity Framework Core avoids this overhead is by caching the parsed expressions. But in this case, the queries at the top, the 2 queries at the top, they're actually treated as 2 different expressions because there's a constant in that lambda. So when Entity Framework Core sees that we want the first movie with a constant of 1, and then we want the second movie with a constant of 2, it treats those as two different expressions and two different cache keys. This can cause performance problems because now every time a new constant comes in, Entity Framework has to parse that and then translate it to SQL and then execute our query. What you want to do is make sure that there are no constants in any of your expressions unless they're always going to be that constant. Let's say you're using like an enum or something like that. That's totally fine. But if it's a changing constant, you want to actually move it out into a variable. And now I've kind of refactored those first two queries, and you can see the variable ID is used. And now when we execute the second query, we're going to hit that cache, and our query is going to be a lot better the second time. So yeah, avoid constants in your expressions. I think this one's going to be hard for people to kind of see, but as you'll see later in the slides, there's a way to tell if you have this problem. Okay, so we talked about how expensive link queries can be possibly, and I've run into this scenario before personally. At some point, your application stabilizes, you kind of know what you need to do. Maybe certain parts of your application have fully baked, you understand what it's doing, it's likely not going to change. This might be a good time to take those expensive link expressions and convert them into raw SQL statements. Luckily, Entity Framework Core has this functionality built into it in the form of from SQL raw method. So here we're able to project back into our movie entities based on the SQL statement that's here. So if there's parts of your applications that are mission critical and you've done everything to tune that performance profile and you've kind of run out of options, just remember you can always go back to raw SQL. The problem with raw SQL, so I just give you a solution. There might actually be a problem here. And the problem is string interpolation. So Entity Framework Core supports string interpolation, and as C# developers, that's what we want to use. It's familiar, it's nice, makes our code more concise, no more string format. So all that's well and good. Entity Framework Core has this method from SQL interpolated, and it's very, very important that we pass in an interpolated string as an argument to this method. When we call this method, the interpolated string is passed as a formatable string, I think. And Entity Framework Core can see that, and it can safely parameterize our values that are passed in with that interpolated string. We may get some tooling that tells us, hey, move this interpolated string into a variable. That's maybe something good to do. And we end up doing that, but now Entity Framework Core can't tell that that string is a formatable string. So now we've introduced a SQL injection attack. Yeah, that's probably not what we wanted to do. So keep that in mind. If you're having to construct SQL statements, especially with string interpolation, you want to make sure to use the from SQL interpolated and actually pass in the interpolated string as I'm showing right here. So querying is a big part of EF Core. And the way it improves performance over time is by querying or by caching queries, especially those created through link. It parses those expressions and it caches those queries internally inside of Entity Framework Core. Looking through the EF Core documentation, I found this really interesting section about NetCounters. Which is a new .NET CLI feature. I'm a big fan of it. I think it's pretty awesome. I'm hoping that we get more visibility into these counters in terms of .NET tooling. But here the documentation says, EF Core's event counters report the query cache hit. And over time, you want to make sure that this counter reaches 100%. Meaning if you've exhausted every single branch in your application, at some point your query cache hit should hit 100%. If over time you never see your application hit 100%, it means you're probably doing something like having constants in your query expressions, or the way that you're generating your link queries is with some kind of crazy expression builder that doesn't give Entity Framework Core an opportunity to cache that expression. So keep this in mind. Install this NetCounters tool, and you can actually check what the counter is while your application is running just through some simple CLI commands. Okay, so that's a little bit about the internal workings of Entity Framework Core and how it can cache things, but you can kind of see where it could potentially cause problems if your DB contexts are too long-lived. Things like internal cache, object tracking, those all get stored as part of the DB context. And if you have a long-lived DB context, maybe you've registered it as a singleton, this is a memory leak kind of waiting to happen. It's kind of hard to do today, especially in ASP.NET Core, with things like the dependency injection framework that's built into it. People who would make this mistake are maybe building console applications. Maybe they're building hosted background services for their ASP.NET Core application. You don't want to keep these DB contexts around very long. They're going to keep references to these entities. You're also potentially going to introduce things like stale data, because if the DB context knows it already has the entity, it might just give you the entity back from a particular query, and that data may have been updated in the database. So if you think you're getting performance enhancements from using a long-lived DB context, you probably have other problems as well. So don't do this. If you really want to avoid the expensive creation of a DB context, and arguably it's not that expensive once things are cached and primed in Entity Framework Core, you can use this new concept called DB context pooling. And it works kind of like SQL connection pooling. DB context will be created and put in this pool, and anytime you need a new DB context, Entity Framework will give you one out of this DB context pool. The nice thing is, once you're done with it and let's say your ASP.NET Core request is completed, that DB context is returned into the pool, and all state in that DB context is completely reset, and you're ready to reuse it. So you don't have to do all that management of clearing the object tracker, and all those mistakes you could run into doing this manually. There are some limitations with this. Remember, these are entities being reused. So if you have to inject any scoped services into a DB context, this approach is just not going to work for you. If you have any private data or private variables in a DB context, know that that data will be shared as long as the DB context exists. So that might not be something that you want in your application. So while this can improve performance and it caches a lot of the internal dependency injection that happens inside of Entity Framework Core, you just need to be mindful of how it works and its limitations. This actually, I just added this slide today because .NET 6 Preview 5 released today, so hooray, right? This kind of stuck out to me in the blog post from the EF Core team. They're claiming a 10x performance increase. The kind of DB context that they're using has 449 entities, 6,390 properties, and 720 relationships. As mentioned in the blog post, and I recommend going to read it, I think I have a bit.ly link over here on the right. A lot of the expense in creating a DB context is associated with the internal dependency injection. And what using this compiled model approach does is it uses source generators to basically cut that startup cost down. There is a limitation to this. Anytime your DB context model changes, you have to recompile this compiled model. And the way to use that is you just say options that use model. But again, keep in mind that limitation of using this. You have to regenerate that compiled model anytime your DB context changes. So this is nice. I haven't used it. I'm curious to see how it actually behaves in a real life application. And I'm curious if folks will go through the trouble of this to save, say, 1 second of startup time. This is probably most important for scenarios like Azure Functions, where you may be starting up a function from a cold start. And that is kind of slow to begin with, and adding an extra 2 seconds can really hurt that kind of performance. So I'm curious where this ends up going and how people end up using this. Okay, so we've set up our environment. We've talked about design decisions. We've talked about querying, and we've talked about the internals of Entity Framework Core. We've gone through the process of really fine-tuning our application, and we're ready to deploy. Obviously, we have a database tool. We've been looking at the counters inside of Entity Framework Core, and we've been measuring our query performance the whole way through. Every developer, every time they write a query, always checks what their query is doing in the database. That's probably not true, but it would be nice if they did. So I really recommend when you're writing Entity Framework Core queries, there is a method called toQueryString. You can call that on any iQueryable that is generated from Entity Framework Core and get the SQL. And then you can actually execute that SQL directly in your favorite database tool and look at the execution plan. You'll see that what that query is doing, what tables it's hitting, what columns it's using to get data back out, and whether it's doing things like full table scans. This UI, if anybody's interested, is coming from DataGrip. Actually, I think this is from Rider using DataGrip. So yeah, it's pretty nice tooling. And the biggest sin a developer could definitely make when they're developing their application and using less than optimal data locally is forgetting indices. Indexes are complicated because as your application evolves, you might want to fine-tune your indices and apply them strategically based on your workload. Sometimes when you're designing, you can foresee where indexes should go, but sometimes indexes and the need for indexes arise from actually using your application in production. Let's talk about migrations and how indexes kind of fit into that. We kind of saw before how migrations sort of work with seed data, but here is a complete migration that Entity Framework Core will generate. I have to give credit to the EF Core team. Migrations are a lot better in EF Core. I would say Entity Framework 6's migration approach was completely broken for distributed teams. Luckily, this is a lot better. It's file-based, and you can diff it. It's pretty nice. I think if you're stuck on EF6 still, I would recommend Fluent Migrator. That was a great open source package. It's still great, and I'd recommend using that. But we talked about different databases. Migrations are actually generated based on the data provider that you provide Entity Framework Core. In this example, I'm showing a migration created using Postgres's database provider. And one of the mistakes that people make when generating these migrations is not realizing that migrations are specific to the database provider. So this doesn't really give you an opportunity to build your entire schema, build up your migrations, and then decide you want to move from Postgres back to SQL Server or to Cosmos. You only really have two options. You have the ability to have multiple migration paths within your project, which I personally don't recommend. There are scenarios where maybe you're building a SaaS app that's hosted, say at a client site, and you could go down that path. But if you're managing an in-house product that only is ever going to deal with one database, your option here is just to completely delete all your migrations and recreate them for your new database provider. You also want to think about how you're going to apply these migrations as you move forward with your application. For me, I found for small applications, it's okay to eat some startup costs and maybe run your migrations at startup. But as your application grows and you start to add things like indices, which can be time sensitive, applying an index on 10 million records in a database, that's going to take a bit of time, especially depending on the scale and performance of your data server. So luckily, Entity Framework Core has the ability to take these code migrations and generate SQL statements that you can apply manually or through some CI tool. But as you start building your EF Core applications, you definitely want to think about migrations, what's going to be applying these migrations, and what specifically do you want to put in these migrations. From personal experience, I find leaving expensive operations like index applications and data transfer from one table to another, leaving that maybe to a manual process or an overnight process makes more sense. And having your migrations really focus on structural changes like adding columns, removing columns, adding a new table. Those things make sense to put in this kind of up-down migration approach. Also, from past experience, I would just recommend having a roll-forward mindset when you're thinking about migrations. While these support rollback, I would not use rollback personally. It's a destructive process. So if you end up dropping things like tables, that might not be good and might not be what you want to do. So thinking about migrations and thinking about roll forward is likely what I would recommend for most teams. And outside the repository pattern, I think this is probably one of the more controversial ideas when thinking about using EF Core. And really, it's should you be using EF Core to begin with? Is it something that will grow with you and meet the needs that you have when solving the problem at hand? I know teams like at Stack Overflow use both Entity Framework and Dapper hand in hand, just to kind of fine tune their application and solve different problems. But looking at the latest Tech Empower benchmarks, if you're performance focused and resource focused, here's a comparison between ASP.NET Core running middleware and running against Postgres. And the only difference here is EF Core and Dapper. The EF Core team has said that There's ways to improve this number. I think this benchmark didn't use DB context pooling. But as you can see, Dapper is way ahead of Entity Framework Core because Dapper doesn't do object tracking. It's not keeping track of all the entities that you're changing in memory. It just assumes the entities that you give it, it's just going to save them directly into the database. So yeah, if performance is a big concern for you, maybe EF Core isn't the right solution. That said, I know the EF Core team recently has said they're 96% the same performance of Dapper in particular scenarios. And I think for these benchmarks in particular, take them with a grain of salt. I don't think anyone's running real world scenarios like these benchmarks. And if you're really building like in-house applications with small teams and small user bases, personally, I think EF Core is more than capable for the job, especially once you get all the benefits that come with EF Core, which is easy prototyping, easy evolution, and a migration framework as well. So think about your scenario. If you're performance-minded, EF Core might not be for you, but for me personally, the EF Core team has really made strides in terms of making the library performant, and I think it'll continue to get better. As a side note, I saw one of the developers of Dapper is starting to look at source generators to take Dapper to the next level in terms of performance. So there's this kind of interesting rivalry right now happening between Dapper and EF Core, and I think we're all going to benefit from that. So that's basically my talk. I've written a lot of these tips in a blog post, so I put it in a QR code here. If you end up taking a screenshot of this should take you to our JetBrains.net blog, where you can kind of see some of this stuff, in written format. And you can kind of try out. I think I have a example repo. If I don't, you could probably go check my GitHub out and find all my EF Core experiments there. So yeah, thanks. And if you have any questions, now's a good time to ask them.
Any questions for Khalid?
I had kind of a question. Like, how often do you? It's kind of a tricky question, I guess, but like proportionally, how often do you find yourself kind of writing store procedures and that kind of just kind of avoiding the ORM part and just doing the typical database stuff?
Yeah, to be honest with you, I don't think I've written a store procedure in probably over a decade.
Okay.
Just because I find that raw SQL and LINQ kind of meet that need. The only time maybe I've reached for a stored procedure is if I needed to do logic-based querying, something that you can't really do through SQL. Maybe you have to loop through things and match them. So there's that. Actually, there was a time I did end up using a stored procedure, but what we ended up doing was calling SQL Server's JSON methods, and then that gave us a lot of performance for what we were trying to do in that case. But for the most part, I would probably avoid stored procedures. Last time I checked, stored procedures and views don't. There's not that much of a performance difference that I've seen personally, but I think I saw Simon raise his hand. Maybe he has more to add to that.
I was going to say I don't think we have any stored procedures, but we have made use of both SQL computed columns and also views, because from any framework's perspective, you can treat a view like it's a read-only table. So often you write, custom SQL code in a view, but then you still get the full power of a mapping to entity framework, and you don't have to, call into the the store procedure and map things back and forth, and you're not stuck with that rigidity because the link syntax is fully supported over views.
Mm-hmm. I think with SQL Server 2, there's the added benefit of views that reference multiple tables are read-only, but if for some reason you have a view over a single table, you can actually write to that view. I'm pretty sure that's a possibility with SQL Server. I'm not sure if Entity Framework Core supports that, but I would imagine that's basically transparent. You'll find out if it works or not when you actually execute that link statement. So, yeah.
Well,
but yeah.
Follow-up question then: raw SQL versus link queries. That's tough to quantify as well, but just maybe in terms of how much time you personally spent.
What was the first one?
Well, the store procedures
raw
or whatever,
SQL.
but now raw SQL versus just link queries.
Yeah, it's tough, right? So with Entity Framework Core, I find that the link syntax gives you an opportunity to build queries dynamically much more easily than you could with raw SQL. You can actually, with Entity Framework Core, build part of your link query with raw SQL and then apply link statements after the fact. So if you're using things like where, first or default, I'm pretty sure it wraps those into, say, a subquery. So your initial SQL query gets wrapped in as a subquery. So you kind of don't have to choose one or the other. You can actually mix and match. I will also say EF Core is an abstraction that's trying to work with multiple different types of databases. Mm-hmm. And you lose some of the power that comes with those databases. I recently just learned SQLite supports full text search. It also can parse JSON. And those interfaces you can't actually access through the link interface. So in those cases, you would have to write raw SQL. So to answer your question, I know I'm maybe rambling a bit, but I would use the raw SQL when using Entity Framework Core to use database-specific features that are not yet implemented in the EF Core interface, the link interface. That said, I know the EF Core team is working on supporting more database-specific features. Spatial types in SQL Server is one of them. I'm hoping for more JSON SQL Server stuff. Cross your fingers, everybody. But those are the kind of things that I would lean more towards using raw SQL. If that makes sense.
I guess I have a follow-up question. Are there incompatibilities then? Have you encountered like a feature in a database that's actually incompatible in some significant way with EF, like object tracking or whatever?
No, I haven't found anything like in the happy path of things. I haven't found anything that maybe doesn't work. I was actually playing around with SQLite's in-memory database connection. So you can actually run SQLite in memory, and but there's a caveat. That database only exists as long as a database connection is open to that place in memory. I found that with Entity Framework Core, you have to maybe jump through a few hoops to keep that connection alive. But yeah, like there's those kind of weird scenarios that maybe are a little bit edge casey in EF Core, maybe don't work how you would expect them to. But when it comes to link queries and SQL generation, it works for the most part. I will say one thing about SQLite. They have a tiny column, and then you kind of, when you're setting up your SQLite database connection or your options, you have to tell Entity Framework whether to treat that column like a Boolean or not. So there's those kind of quirks, but I feel like Entity Framework Core and the people building the database providers are doing a good job of at least exposing those quirks so that you can kind of tweak them.
Gotcha.
So, yeah.
Okay, thank you.
Oh, you're welcome.
What are you running your tests against?
Tests. Who writes test now? I'm mostly writing demos these days, so I'm not really writing a ton of tests. Just kind of sample applications. But if I was to write tests, I'm a really big fan of integration testing. So run your database that you would in production or something very similar in a Docker container. I mostly develop on Mac OS. So I have Docker for desktop. I run SQL Server for Linux inside of a container. And you can actually spin up, there's a open source library called Fluent Docker that you can actually spin up containers per test harness and create these unique database instances for your tests. I would also probably use verify if there's snapshot testing as a way to just verify that the result sets that I'm getting back are what I expect. So shameless plug for Simon.
we're all Windows based, so we use LocalDB. So we spin up a unique SQL database per unit test method, which is actually surprisingly fast because you just have a default MDB and log file, and you remount it for each test under a new name.
Yeah, when I used to develop on Windows, I used LocalDB as well. It is surprisingly fast. I mean, it'll never be as fast as, say, an in-memory database. But to me, that's probably one of the pitfalls that I think people run into as well. Entity Framework Core ships with an in-memory data provider, and it sort of works, but it doesn't work like a SQL database does. It uses link to objects. So it never actually translates your link queries into SQL, and objects in memory definitely don't behave like a SQL database does.
One of the common scenarios for that hit us when we first tried in memory was that when you do a query, you have to say what extra things you're including, like, nested data structures as part of a link. In memory, it'll just happily plaster over the fact that you've forgotten to include things and give you back a valid instance of something because, the whole thing's in memory. Includes mean nothing. So you don't hit the bug until you get to production. So we banned in-memory testing.
Yeah, I mean, I wouldn't go so far as to ban it, but it's obviously flawed. And personally, it's one of those things that if you're using Entity Framework Core, I just don't understand why you would use the in-memory data provider. I'm not sure what it brings to the table, especially since you're using Entity Framework Core, you're likely going to use a production database. So maybe it's a holdover from Entity Framework. And I know a lot of the community ended up building in-memory database stubs for the old Entity Framework. So the Entity Framework team maybe just carried that over into Entity Framework Core proper. But yeah, I personally would not recommend using it. I don't really know what its use is outside of being kind of a toy, really. So it's funny, Simon, that you said you banned it, though. So I'm just curious, the scenario where everything was on fire and then you all looked at the in-memory database provider and realized, oh, this thing lied to us.
Well, it wasn't so much everything was on fire. It was, you want a certain level of trust in your unit test that you have, you are doing the correct thing. But, it was slowing down dev so much when people were, writing a feature, deploying it to the integration environment and saying to the front end people, here's the, feature for it. And, it just doesn't work. And you go, oh, and it's just, it's a pit of failure, right? You just constantly fall into it no matter what you do because it's so easy just to forget and include.
Yeah, it's interesting too, like with Entity Framework Core removing the lazy loading, in those in old Entity Framework core, lazy loading may have stepped in to kind of save you. It would eventually appear as a problem, but maybe it could patch over your mistake. Whereas with Entity Framework core, with lazy loading disabled, forgetting that include is almost immediately apparent that you just don't have this data. That said, if you're using link methods like average or count on those sub entities or sub collections, you'll just get a value that's not what you expect, right? So in my example, I had the average method. Yeah, your average rating will always be 0 because you never included any of the ratings. It's interesting. So Simon, you're using Entity Framework Core today, or are you still using Entity Framework 6?
No, we moved over fully to Core. I don't know, version 5, I think. I mean, what, they started version 4, didn't they?
I think there was a 3, but I'm not really sure. I've been
over a year.
Yeah, I've only noticed really with Entity Framework 5 is when a lot of the many-to-many mappings have really kind of solidified with Entity Framework Core. Only recently could you have a transparent many-to-many table, and Entity Framework Core could recognize it. For a long time, you actually had to model that many-to-many join table. There are scenarios where you want to do that, like if your relationship has properties that you want to apply to it. Like let's say you have a person table and a person has friends. Well, you may want to describe what that friend relationship is like, whether they're best friends or casual acquaintance. That's when you actually want to model that many-to-many relationship in your DB context. But otherwise, those many-to-many tables can just be transparent. So, yeah. But, yeah.
So, Khalid, while you were talking, you asked us to boo you, but, instead we made fun of you on Twitter. So, yeah. Take a look at that at some point. Can we get the slides for this talk? Because I've had a bunch of people already ping me and ask me, where are the slides? Where are the slides? And I'm like, I don't know.
Yeah, I'll generate a PDF and I'll send it to you, and you can kind of put it in the show notes.
Sure. Sounds good.
Yeah.
I had a question for you. Entity Framework Core, obviously it supports multiple database providers, and most of the applications these days are polyglot. So have you do you have any downsides or best practices for using different database providers within the same project, very in close proximity to each other, for lack of a better?
Yeah, I mean, the only thing I can speak to, and maybe Simon can kind of jump in and give his perspective, or anybody here can give their perspective. But from my past experience, usually when building a web API, you have kind of your search endpoints, things that allow users to kind of look through like a lot of data. And the approach that I would take is have those particular endpoints powered by a different database. For me, Elasticsearch is an amazing search provider. It's really fast, like it's crazy fast. So for me, think about the functionality that you want to expose out of a particular endpoint, and then pick a database that will power that particular endpoint. For me, search is normally Elasticsearch, and then any data that had to be essentially real-time or ACID compliant, meaning like it could never be stale or the users would be really, really confused. That's when I would lean on something like Entity Framework Core and a relational database. I've seen people try to power search through Elasticsearch and then return a bunch of IDs and then go to the database and pull those records out with IDs. But I've just found when it comes to search, it's normally okay to have stale results. And normally they're not going to be stale because Elasticsearch is so fast. But that's how I'd recommend putting multiple databases into one application. Pick what that database is good at, pick your endpoints, and then use that data. You'll have to create sync mechanisms, though, between your relational database, which is likely the source of truth of data. You can do that through a background process, either through message buses or even event systems. So I'll leave it up to the architects to figure out how to do that in particular. But Simon, do you have any thoughts?
So we have in the past used N-Service Bus to farm off events and keep a different database in sync. In the current stuff we're doing, it's not. We just don't have enough users to justify.
Mm-hmm.
We don't need to scale out requirements. But one little hack we have found in terms of improving the perf, kind of on a slightly different topic, but improving the perf for individual users, we've implemented the 304 handshake pattern where they send through an e-tag or a last modified, and you give back a not modified.
Mm-hmm.
So every entity in our database has a row tracking that increments. So, and we just, before we return any response, we just check state of a database, what's the current row tracking number, and then we use that as the e-tag.
Mm-hmm.
So it means 90+% of requests end up with a not modified going back, and that significantly improves the performance of the client and decreases the load. And it's a really simple thing to implement.
Mm-hmm. Do you have a blog post on that? I'd love to read it, because I guess in the past when building APIs, I think caching is one of those undervalued features of the HTTP spec.
Mm-hmm.
And there's
agreed.
There's this talk, I forget who gave it, but it was about database caching, and I think the recommendation was to scale your application, you need only have a 1 second cache. Like, how long? Like, can your database handle 1 request a second to infinity? And most databases can do that. And if you just set a 1 second cache on all your queries, it'll be real time enough for most users, especially when you're returning a result set of multiple entities, and it could help improve performance of your application. That said, the thing that you described is really caching at the HTTP layer.
And no stale results.
Mm-hmm.
So it's so what you do is there's a couple headers in HTTP where one you can say, look, cache this thing forever, or as much RAM or disk as the client has, up to the client, but also revalidate every request.
Mm-hmm.
Right? So they keep that cache forever, but every time the browser says, oh, what's this resource, it'll just do a 304 handshake, say, oh, is that valid?
Mm-hmm.
And there's one more that you can do to improve performance where you can say use stale while revalidating.
Mm-hmm.
So the browser says, oh, I've got this thing, I'm going to revalidate it. Server has said, look, it is stale, but look, the next time you request it, just get the new version. So it returns the stale version for that request and then updates its cache in the background.
Mm-hmm.
So that's where you can say for certain resources where you're happy for them to be a little bit stale, you can leverage browser caching as well. And this is it's all basically text in headers. It's so simple to implement, no resources server side.
Yeah. Do you use a library like Cash Cow to kind of manage the headers in ASP.NET Core, or did you just kind of home roll your own solution there?
So the majority of our headers are 100% static. So we write them on every request.
Oh,
and
okay.
the logic for doing the other stuff, it's not that much code at all. So there's no, most of those caching libraries in .NET are focusing on, server side logic of caching stuff in memory or, concurrent dictionary lookups. But when you're talking HTTP, it's cross machine state. So there's no as far as I know, there's no tools out there that leverage this for you.
Mm-hmm. Okay. Santosh, you definitely have another talk coming because I'd love to watch that. I'd love to
Awesome.
see how it's implemented and the specifics in ASP.NET Core. So, yeah.
Yeah, a couple of things I also wanted to mention that you brought up really good points. One is, you talk about always rolling forward with the migrations, and I think that is definitely that gets the DevOps stamp of approval from.
That's good.
So the other thing is, you talked about source generators. Just a plug that we have a source generators talk by Jason Bach coming up on July 1st. So it's not too far off from today. So definitely join us for that.
Cool.
Yeah. Anyone else have any questions? I mean, I want to, take a minute to thank Khalid and also everyone else who joined because, we are basically stuck on calls all day long, and then to hop in after work and then, you're doing a talk and other people joining us. It's really awesome.
Yeah. Thank you, folks, for including me. I think Simon has another question. Go ahead, Simon.
Yeah.
Oh, your mic's not working.
Mute.
There we go. There's a bunch of warnings in Entity Framework where it detects certain scenarios that it doesn't treat as errors, but you can opt into treating those as errors. Is there a common list of those that you use?
I just ran into those warnings like last week. So I don't actually know the full list. I think I'm going to go to the Entity Framework core documentation and look for them. I think the one that really stuck out to me is if you try to use skip and take without an order by, it'll definitely warn you and say, hey, you're going to get inconsistent behavior if you forget to order in your queries.
Yeah, that's the row limiting operation without order by. That's the actual name of the ID. So yeah, that's one of the ones we have set to be an error.
Mm-hmm.
So yeah, it basically means if you say give me a subset of results, but you haven't defined an order, it's inconsistent results.
Yeah.
So yeah, there's a bunch of those you can configure them to be errors.
That's pretty cool. I'm gonna have to go look at that. Maybe I'll update my talk and add a new slide. So, but yeah, again, I was thinking to myself, I'm sure people are gonna walk away from this and think, so should I use Entity Framework Core or should I not? And I would say the benefits of Entity Framework Core greatly outweigh some of the bottlenecks. I will say it's still an ORM. It still has leaky abstractions. It's not going to magically write the best SQL for you. It's going to translate what you write. So you have to understand, A, the abstraction, and B, the SQL that it ultimately generates. So Entity Framework Core is not an excuse to not write SQL. And if you think it is, you're going to be hurting. So that's really what I would say. But I would recommend Entity Framework Core. I think it's a good tool. So, yeah.
Thanks. Thanks, Khalid. I think that was a great talk. In fact, I'd say, I used Entity Framework. I haven't used Core quite a bit because lately I've been more, on backend infrastructure side of things. So I haven't used this lately, but I can certainly see where I pretty much made every single one of the mistakes you mentioned on here over the course of my career. So, awesome illuminating talk. Thank you very much for, educating me.
Oh yeah, thank you. And again, we're all human. We're going to make these mistakes. It's about identifying them and hopefully fixing them and evolving our applications. So, again, thank you, folks, for having me. Is really fun talking to devs, and thanks everyone for asking questions. Thanks, Simon, for giving your viewpoint. I appreciate it. So,
Thank you.
Yeah.
All right. Bye.
Thanks, everybody. Have a good night.
Bye.